Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve a question from mechanics, and the paper code is 9709/42. So let's start reading the question. We are going to solve question number 7, and it says two particles P and Q of masses 2.5 kg and zero point 0.5 kg respectively are connected by a light inextensible string that passes over a small pulley fixed at the top of a plane inclined at an angle of 30 degrees to the horizontal. Particle P is on the plane and Q hangs below the pulley such that the level of Q is 2 meter below the level of P. They told us to see the diagram. Okay, we can see this from diagram. Particle P is released from rest with the string taut and slides down the plane. The plane is rough with coefficient of friction zero point 0.2 between the plane and P. And first question asked us to find the acceleration of P. We are going to find acceleration. So there are two particles. That's why we are going to resolve them individually. First of all, let me draw a figure for particle P. Let's see, let me draw the figure for P. Just let me draw over here. So the scenario for P is actually, suppose this is the particle P which is sliding down. Okay, it is sliding down, and here the angle is 30 degree because this one is also 30 degree. So the same angle, the measure of angle will be same as here, and this is our weight. Okay, weight always acts downward, vertically downward. This is our weight, and this is horizontal component of weight. This is horizontal component of the particle, not weight, and this is the vertical component of weight. Now we are going to find acceleration. For acceleration, we know we are going to apply the concept of Newton's law of motion. And for particle P, let it be written for particle P. Let me write it just beside here for P, for particle P. Okay, the concept we are going to apply is Newton's law of motion, and which is driving force minus resistance force is equivalent to mass into acceleration. Now, for particle P, from the question we have come to know that there is no external driving force except the weight. Only weight is causing it sliding down, as I have shown over here. You can have a look at the figure. That is, P is coming downward, sliding down due to the weight. So, weight is the our driving force in this case. Now, weight is, look at this. This is actually weight. Okay, weight is acting vertically downward. This is neither horizontal nor vertical force, com- vertical elements of the force. So first of all, these weight will have to be resolved horizontally as well as vertically in term of our plane. Look at this, this is our plane. Okay, now from the for this plane, this is actually vertical line, this is our, sorry, horizontal line, this is our horizontal line. So if we calculate this, we will find W is actually our mass into acceleration due to gravity. So that is mass into acceleration due to gravity. And as we don't need actually weight, we require the horizontal force. Horizontal force is this one, but in terms of this figure, look at this figure look like this. Okay, and as we are asking for this one, this is now vertical. According to this triangle, it's vertical line. So for vertical line, we can use mg. Mg is this hypotenuse, so mg sine 30 degree, because our angle is 30 degree. This is the only driving force in this system. Then we will subtract the resistance forces. So first resistance force is negative T, tension. The another particle is connected to this, and that tension is acting as resistive force. As tension is pulling it backward, that means resisting the forces, that's resisting the motion, that's why this is tension is negative for P. Then another resistive force for P is actually frictional force, because the plane is not smooth. It is written, look, the coefficient of friction is zero point 0.2. That means it is not a smooth plane. That's why it is causing resistance. So let us find the resistance force. For resistance force, actually the vertical line means this one. This one is the, let me change the ink. So this is actually our resistance force. Resistance force, how to calculate the resistance force? We know for frictional forces or frictional planes, if the surface is rough, then the frictional force is mu r. Not frictional force, resistance force is mu r. So let us write mu r. So it is going to be, let me change the color of the ink, mu r. Okay, r means normal force. Let me erase this part. Equal to ma. Okay, so what are the forces we have got here? First there is weight. Weight is mg sin, that means weight is the driving force, and the resistance forces are tension as well as frictional force. And how did we get this? The weight is mg, actually mass into acceleration due to gravity. We require actually the forces to be resolved horizontally and vertically. And here, as the particle is sliding down, we can just show this symbol over here. Okay, the particle is sliding down. Well, then let us calculate. Mass of particle P is actually 2.5. Let us write here 2.5. Okay, so 2.5 into acceleration due to gravity is 10, and sine 30 is actually half. So let us write half minus tension, and mu is actually coefficient of the friction, which is zero point 0.2 r. Now we will have to calculate r. R is actually normal reaction force. So let us find the normal reaction force. For that, I am going to draw another figure, or this from the same figure we can explain. Actually, this is the normal reaction force, which is acting upwards, and downward is only this due to weight. Okay, so it is going to be, let me erase this bracket. So normal reaction force is actually the net force acting downward and vertically upward. So as there is no upward forces acting there, only downward force is to be calculated. So we are going to multiply by, this is our, due to this weight we can resolve this vertically. It is going to be mg. M is 2.5, g is 10, and then for vertical force, look at the vertical line is, it is actually horizontal line. Look, if the figure looks like this, here is the angle. So we are asking for about this. Okay, so this is cos 30 degree, cos 30 degree, minus, not minus, equal to right side. Our right side is ma. Right side is equal to ma, and m is, we know the mass of the particle is 2.5, so 2.5 a. Then we can simplify this. If we simplify here, it is going to be 5, 2.5 into 10 over 2, that is, it is going to be 25 over 2. 25 over 2 minus tension, minus, if we multiply this and sum up, I mean the simplify, it is going to be 5, then 5 cos 30. So 5 over cos 30, we know cos 30 is equal to 5 over cos 30 is root over 3 over 2, and right side is 2.5 a. 2.5 a. Well, then if we simplify, we are going to get 25 over 2 minus 5 root over 3 over 2 minus 2.5a. We are just isolating tension to the other side. Then we can leave it as equation number 1. Okay, so this is equation number 1. Equation 1. Okay, we have already formed an equation using the particle P. Then there comes particle Q. Let us see the state of particle Q. Look, this is particle Q. Here Q is hanging through this tension. So let us draw a figure for Q. Let me draw over here. Suppose this is Q. Okay, this is Q, and the upward force is actually the tension. Okay, upward force is, this is tension, and downward force is actually only the weight, only the weight. So weight is here zero point 0.5 into acceleration due to gravity. So this is, these two are the only forces acting on particle Q. So let's start writing for particle Q. For Q, for Q, and as that is, it is actually going upward, so let us draw upward mark. Okay, then let me resolve the forces of Q just beside this. Well, it has sufficient space over here. Okay, let me draw the figure for Q. For Q, for Q, for Q, it is going to be downward. Okay, and we are going to apply the same concept of Newton's law of motion, which is driving force minus resistance force is equal to mass into acceleration. Well, so our driving force is actually nothing but the tension, because tension is pulling it upward. So we are writing tension, and resistance force is also nothing but the weight. So weight is mg, that is vertically downward. So this is actually vertical force, mg equal to mass of particle Q is, let us see the mass of particle Q. Mass of particle Q is zero point 0.5. It's zero point 0.5. So let us write here 0.5 A. 0.5 A. Okay. Then we are going to write here tension minus mass is zero point 0.5, and we know acceleration due to gravity is 10, equal to zero point 0.5 a. If we isolate t, then t is equal to 0.5 a plus, if we multiply 10 by zero point 0.5, it is going to be 5. That may be the equation number 2. So we have got two equations. Let us see the equations. The first equation is this. This is first equation. This is our first equation, and this is our second equation. So we can resolve this equation simultaneously. Let me draw a line over here. So what are these? It is 25 over 2, and let me write one sentence resolving the simultaneous equations. So from equation 1 and 2, from equation 1 and 2. So what are we getting? Equation 1 is, let me show you again. Equation 1 is what? 25 over 2 minus 5 root over 3. 25 over 2. 25 over 2 minus 5 root over 3. 5 root over 3 over 2 minus 2.5 a equal to equal to equal to the tension of the second equation is this 0.5 a plus 5. Well, then if we simplify this, it is going to be 25 over 2 minus 5 root over 3 over 2 minus 5 is equal to zero point 0.5 plus 2.5. It's actually 3. 3a. 3a. Okay, so if we simplify here, what is it going to be? 2, then 25 minus 5 root over 3 minus 10 minus 10 is equal to a, and if we transpose this 3 to the other side, it is going to be 3. Hence our a is going to be, a is equal to, let us calculate. So using my calculator, I get 25 bracket 25 minus 5 root over 3 minus 10 over 6 equal to, it is showing 1.0 5 8. So if we round it up, it is going to 1.06 meter per second square. Okay, meter per second square. That is what we are required to find. So what have we learned from this one? Let me go back to the first part. Actually, there are two particles, and both the particles are connected with a tension with the string. So individually we'll have to find the forces, we'll have to resolve the forces. First, for p and in both cases we have applied the same concept of Newton's second law of motion, which is driving force minus resistance force is equal to mass into acceleration. Now if we talk about the particle p, then P is having no external driving force or pulling force. Only weight is causing it sliding down. So weight is the actual force. But weight is neither horizontal. Look at this. Weight is acting downward like this. Okay. So this is neither horizontal nor vertical. So we have resolved the forces vertically as well as horizontally. So how did we write? We have written first that is weight, and if we dissolve it horizontally, we will get, look at this, this is actually now our vertical line. Though this is horizontally, we are resolving horizontal, this is horizontal parallel to the plane, but in term of this triangle it is vertical line. That's why it is mg sine 30. Minus tension is the working, it is pulling it back. That's why it is negative force, we are subtracting. Then the major force, resisting force, is actually mu r, frictional force. So frictional, we know the formula for frictional force is mu r, and mu is the actually coefficient factor between the plane and the particle. So we have written here the mg sine 30 means half, then tension is negative, and mu r, that is also negative because it is causing resistance to motion. Ultimately we have got, for the first equation we have got that 25 over 2 minus 5 root over 3 over 2 minus 2.5 is equal to tension. Similarly, for the particle q, we have got one more equation, which is let me show the particle q. Particle q is actually hanging over here. Okay, and for there are two forces opposite to each other. The downward force is actually weight, nothing but weight, and weight is our mg. Okay, we know the force of weight is ma or mg, and upward force for particle q is actually the tension force. Tension is, the string is pulling it upward. So only there are two forces acting over here, and they are opposite to each other, so subtraction. So 10 driving force is tension, negative force is weight, equal to 0.5 a, and we have got an equation. This is our equation for particle q, and then solving the equations simultaneously, we have got that acceleration is 1.06 meter per second. So this is what the solution is. Let us read the question number b. Question number B is on the next page. Let me show you. The question number B says, yes, this is B. use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Well, for that we will have to the go back to the figure. Let me show you the figure is this, okay? And here, look at this. Actually they are telling P is sliding down, okay, sliding down over here, and Q is going upward like this at some stage, and the distance between the height is actually 2 meters. This is 2 meter distance. So they are telling that when suppose Q has reached up to this and P has come down up to this, at this stage they told to find the work done by the particles. Well, so for this I will have to draw the figure individually actually, because the distance, look at this, P is traveling the distance in this way. It is not vertical distance, but Q is going upward, vertically upward. So there is a difference between these two. Directly we cannot find them out. That's why let me draw the figure individually. From this figure we can assume that suppose this is P, okay, P is coming down, P is coming down to on this, sliding down on this plane this way, and Q is going upward, okay? So height at this height they suppose they reached up to this, but as this for Q this is straight away, this is height, we can suppose it to be height, but for P it is not actually straight height, this is actually distance. So we will have to find how much was the height at that instant. Suppose P has traveled x meter, so Q will have to also travel x meter, because both of them are having same or equal acceleration. So this distance is x, this distance is x, this for P also the distance is x, but we are actually to find, we require the height, not distance, displacement. The displacement for P is actually this one, look, this one is the displacement for P. So please don't get confused. In case of P has traveled this distance, this is the distance, but we don't require actually distance, we require displacement, means height, how much was the height it has covered. So for P we will find this one, and both of them actually have traveled the equal distance. So let us see total distance from Q. Look at this, from the figure we can see it is written that the total distance between them was, what was the distance, this is 2 meter. Look here, it's written that it is 2 meter distance between them, a height in between them is 2 meter between the particles. So our total distance is going to be 2 meters, okay? Let me zoom it out. Well, now suppose at this height, okay, suppose at this height they have reached. Well, so for this height we should know actually how much distance has been, not distance, displacement has been done by P. Suppose this is x, okay, if this is x, this is horizontal, not horizontal, this is hypotenuse. So for P, let us write let the distance, the distance traveled by each particle be x meter, okay, x meter. So for Q it is x already, because this is going upward vertically. Now for P we'll have to find that this is our height for P, okay? So we will have to find h is equal to hp, height of P which has been traveled. P is equal to x sine 30, because angle was 30, x sine 30. Well, x sine 30 means 2 over x, and we know that the total distance, so this is the distance, I mean displacement covered by P, and Q has covered x, this is the distance or displacement covered, distance and displacement in case of q is same because this is vertically upward, but for p it was different. Okay, so total distance from here to here, total distance was actually, total displacement or total height was 2 meters. So we can write x, x is for q and x over 2 is for p, total is 2 meters. Now if we simplify this, it is going to be 3x over 2 is equal to 2. Hence our x is going to be 4 over 3. So x is actually the distance traveled by q is 4 over 3 meters. Now the height of, we are supposed to find the height of p. Height of p is not actually x, it was x over 2. Look at this. So for p, so height of p we can write, or displacement of q, whatever you tell, height of p is equal to, it is coming downward, so 4 over 3 over 2 because it was x over 2, that means it is going to be 8 over 3, sorry, 4 over 6, it is going to be 4 over 6 meter, 4 over 6 meter. This is the displacement or height traveled by p, and 4 over 3 meter is the distance traveled by q. So let's start work energy method, because the question told us to use, and look at this question, use an energy method to find the speed of the particles at the instant when they are at the same vertical height. So we know the work energy method is work done by driving force, work, let me change the ink, work work done by driving force is equal to change in GPE. As there are two particles, we will calculate individually. GPE first for P, and then plus GPE for Q plus, or can I write the formula just simply? No, let me write individually, it will be better for you to understand. Then change in kinetic energy for P plus change in kinetic energy for Q, change in kinetic energy for Q, then plus work done by resistance force. Okay, and the driving force, actually if we go back to the figure we will see that, let's see the figure. Here it is, look at this, the question told that particle p is released from rest with the string taut and slides down. So it is actually sliding down, it is sliding down, there is no external force pulling it downward, that's why driving force is actually 0. Our driving force is going to be 0, let us write 0 over here, so 0. Then change in GPE, change in GPE is for P, so mgh plus this is for P, then mgh for Q. Okay, then plus half m v square, change in kinetic energy, the formula is half m v square plus half m, this m is actually for P, and this is mass of Q v square plus work done by resistance force. Now let's see what are the resistance forces. If we look at the figure, we will see this is our figure. Okay, and for these one P and Q, what is the relationship between Q? Actually for Q, look at this, there is no resistance force, external resistance force, except Q, I mean except weight. So for Q there is no resistance force except weight, and weight is dissolved by the potential energy. So in case of resistance force, Q is not being considered at all. Now it is all about P. So for P, resistance force is frictional force. We can see what was the frictional force for P. It was actually this one, not on this page, it is here. Okay, so frictional force we have already calculated. This is our frictional force for P. Well, so this is what the frictional force we have already calculated. So frictional force is actually ultimately 5 over, let me write it in elaborated format. So it is going to be, so resistance force of P into S, because we are talking about work. This is actually S, or left side is 0, so it is all about P. The mass of particle P is 2.5 into G is 10, and height. Now let's see how much was the height. We have already calculated for P. The height is this one. This one is the height, so 4 over 6 meters. Okay, but let us see, P is actually going downward. Look, this is P is coming downward, so height will be negative initial, because we are finding the difference between the heights. So initial, if it is initial height is over here, then our reference line is here. So as it is going downward, so it, for P it is going to be negative, because we are finding the difference between the height. Okay, so let us write negative. How much was this? It was actually 4 over 6, and it will be negative in case of P. So negative 4 over 6, plus mass of the particle Q is zero point 0.5 into 10, and height of Q, that means the distance traveled by Q was, what was it? It was, we have got, for Q it was X. X means 4 over 3. It is 4 over 3 for Q, because Q was just going upward. Q has gone upward. Yes, this is the distance for Q, and it is 4 over 3, and it is not negative at all, because reference line is here. Look, this is the reference line, and it has gone upward, so final destination is more. That's why height will be positive in case of Q. So we will write here 4 over 3. Well, then there comes, let me write just beside this, then there is kinetic energy, plus half, plus half. Mass is, our mass is what for Q, for first for P it's 2.5, so 2.5, 2.5, then V square, plus half mass of Q is zero point 0.5, then V square, V squared. Okay, now the question is about the resistance force, plus resistance force. Already we have discussed that there Q doesn't have any resistance force, because suppose this is Q, it is just going upward, and the resistance force acting on it, it is actually weight. Okay, mg. And as there is no mg, this mg has already been dissolved through potential energy, because it gained potential energy. So for Q there is no resistance force, there should be no question about Q. Now for P, P is, look at this, P is going down, sliding down, and it is facing a resistance force which is acting over there, and the resistance force was actually mu r. Okay, mu r, it was, mu was zero point 0.2, and r we have already calculated in the previous question. It was, what was r? 5, or let me write mg. If we write in elaborated, it may be better for you to understand. It is going to be, so r was, mgm was point, sorry, 2.5, 2.5, and g was 10, and this is cos, not sine, because we are talking about the vertical force, vertical component, which is cos 30, and our angle was actually 30. If we look at this, where have we got this 30 from? Let me show. This is, look, here the angle is actually 30 degree. Okay, this is our angle, this is 30 degree, and our force is acting actually this way, sorry, this way. Okay, from the previous figure you can get it more clarified. Well, so it is going to be, if we calculate this, okay, we have written all of the components. Now the another question, look at this. As we are talking about the resistance force, what about the resistance force of P? Look at this. For P, it is, tension is also acting as resistance force. Why are we not calculating the tension force? Because the reason is, for P this is resistance force. Okay, at the same time it is, the tension is, I mean the string is pulling out or pulling up Q. So whatever is the resistance force for P is the same driving force for Q. So the same tension, the same tension is dissolved by each other. That's why resistance force of tension is not counted for P, because this is actually the driving force of Q. As the quantities magnitude is same, so it will be actually dissolved. So tension has been dissolved by each other. This is their internal force. It is not external force applying on them. That's why actually tension is not calculable here. I think you have understood. So let's see, our equation is this. Okay, let us calculate. So left side is our 0 is equal to, if you calculate here, it is going to be 25, and so negative 60, so negative 10. It's actually negative 10, and it is going to be 40, 40, so 5, 20, it will be 20 plus 20, isn't it? So it's a 5 4 20 over 3, sorry, there is a 3. Then plus, if we, this is what, point 2.5 v square, plus it is going to be, let us do addition, 2.5 0.5 is, so 3v square, 3v square over 2, 3v square over 2. Then plus our resistance force, it is 25 2.5 and 10, 25, 25 into 2, that is 5. So 5 cos 30 means actually root root over 3 over 2. So this is what our quantities are. Now if we calculate, let us simplify this, or 0 is equal to, it is going to be 2, so negative 20 plus, oh, sorry, it is going to be 6. It's a great mistake. It is going to be 6. LCM is going to be 6. If we multiply all of them by 6, it is going to be negative 60 plus 3 to, so 40 plus 3 9 v square plus 3 15 root over 3, 15 root over 3. Sorry, we made a mistake over here. It should be, let me erase this part, this step should be erased. Okay, so it is going to be actually, let us write again. Well, 0 is equal to, 0 is equal to, if we, not this one should not be 10, negative 10, it will be actually 42.100, it's actually 100 over 6. So if we simplify, it is 6, negative 100 plus 40 plus 3 9v square, 9v square plus it is going to be 3 15 root over 3, 15 root over 3. If we do cross multiplication, it is going to be negative 100 positive 40, so negative 60. So negative 60 plus 15 root over 3 plus 9v square equal to 0. Okay, or 9v square is equal to, 9v square is equal to 60 minus 15 root over 3, or v is equal to square root over 60 minus 15 root over 3 over 9. let us calculate using our calculator. It is going to be v equal to, hence this is the last step. So hence v is equal to, v is equal to square root over 60 minus 15 over root over 3 over 9. Using your calculator, you will get this is 1 point, if we round it up, it is going to 1.68 meter per second. Okay, so that is what we have solved. So from here, what have we learned? Actually, let me show you. The confusion may arise. We know the energy method. They told us to find the velocity using energy method. Energy method is, it is actually driving force. That means work done by driving force equal to change in GPE plus change in KE and plus work done by resistance force. Okay, now as there is no applied force acting over here, so resistance force, driving force is zero. And for, as there are two particles, I have written them individually, you can write them combinedly also. So first we have got the change in GPE for P, then for Q, then kinetic energy for P as well as for Q, then the resistance force. All of them are all right. In case of particle P, as it is actually going downward. Okay, so that's why for particle P, height is, height is negative, but for Q it is going upward, that's why it was positive. Then the question is resistance force. For the resistance force, here we have calculated, only we have calculated the resistance force of P. Why not Q? There may be a question which can arise in your mind. So the answer to your query is actually P is pulling the word. Okay, suppose P is here, P is pulling upward. So for P, the tension is working downward. But at the same time, for Q, it is actually driving force. For P, whatever is resistance force, same force is acting on Q for as a driving force. That's why actually both of these forces, as they are opposite to each other direction, then they dissolve each other. That's why tension has not been calculated. And for Q, for P, we have calculated this resistance force. Look at this, this is the resistance force. But for P we have calculated, whereas for for Q we didn't calculate, because Q doesn't have any applied force at all except the tension. And I have already explained why tension has dissolved each other. And only weight was resistance force for Q. Weight is not calculated in case of work energy method, because weight is due to the change of potential energy which has already been calculated. So for P, only resistance force worked here is frictional force, and we have calculated the frictional force is actually mu r. Mu is zero point 0.2, and our r is, we have already calculated, mg cos 30 degree. I tried my level best to make you understand this. I don't know how far have you understood or not, yet I will keep on trying to explain the tiny parts of the complicated solutions. So please pray for me to Allah or Almighty Creator, so that I can do better and better in the upcoming days. Before I end up, I will have to rectify one mistake. Actually, look at this. In this one, work done against resistance force is resistance force into displacement. Displacement was what? It was actually 4 over 3. Okay, this was x was the displacement. I forgot to calculate this, so it will be 4 over 3 will be multiplied here. Okay, if we multiply it by 4 over 3, it is going to be 20. Okay, it is going to be 25 fours are 20, and then it is going to be 20 root over 3, and it is going to be 3 twos are 6. Okay, now what are we going to get? It is going to be 20 root over 3. It's 20 root over 3, not 15 root over 3. It is going to be 20 root over 3. So 20 this will also be 20 root over 3. then 20 root over 3, instead of 15 it is going to be 20 root over 3. Okay, 20 root over 3. Then you will get actually this answer, because my calculator showed a different answer, because the number was written wrong. So this is what the explanation is. I have tried my level best to make you understand. Okay, thank you all.